Thanks for everybody attending tonight. It's a good crowd. I think it's one of our largest crowds this year. So we're going to go ahead and start house chores. We've got quite a few announcements tonight. I know people are still coming down from Buckhead, so we might start the presentation a little bit later than. We want to go ahead and say thank you to Kabbage and to Candid Partners, our sponsors for this evening. In fact, Sarah's over here from Candid Partners. I want to give her a few minutes to give an introduction to herself.
Thank you. Hi, everyone. Thank you so much for being here and allowing us to sponsor this event for you guys. It's nice to meet everyone that I have met. If I haven't met you, swing on over. We have some information about Candid. We're a cloud consulting firm based out of the Biltmore building, which is right over off of 5th Street. If you're ever there, swing on by. And if you have any questions about Candid, just let us know. We do work in AWS specifically, but we've also moved towards a multi-cloud approach this year. So I'd love to hear any of your expertise in Azure or GCP. If you have it, I'm here to listen. Thanks again.
Anybody from Kabbage want to talk? Okay. We do have quite a bit of announcements tonight, so that's one of the reasons we want to start early. I want to let everybody know we had talked about doing a tech barbecue tomorrow, which unfortunately is going to have to be rescheduled. We're going to do it either in August or July. I want to get some of the other meetups organized with it, so it's kind of a more of a joint thing. We usually do a bear blast in August, but instead of the bear blast, we'll probably end up doing this tech barbecue. It'll be a lot of fun. We'll get a lot of the other tech communities involved. I also want to introduce you to Matt Gold. He is also the co-organizer of Atlanta Angular.
Woo! Yeah, I mean, we've been using Angular here for a while. I've got about 3 to 4 years of experience with it. I'm just super excited to finally get involved with the community and help out with this kind of stuff. So really happy to be here.
Yeah, I'm happy he's here too. All right. All right, Vincent, is he still here? Where's he gone? Oh, there he is. Vincent?
Hi, everyone. So Connect Tech is a conference here in Atlanta every year. It's now the largest front-end dev conference in the country. So we will have dedicated React, Angular, Vue, and Node tracks, as well as some other things. We may even have somebody from the Angular core team do a keynote. Could be Misco, could be someone else. But we want you guys to think about submitting to the call for papers. It's open till May 1. You can reach it at connect.tech. And please put in a session. We'd love to have you guys come and speak. This conference has grown since Darren. Where's Darren? First went there. But so there's plenty of people that now speak around the world that did their first talk here that had never even spoken before. So please put a talk in, and it could help you. And there is a $50 discount for the conference. So if you take a note of that code there, ATLNG Meetup. And basically it takes until May 12th. This will get you the 2-day conference for $300, which for a 2-day enterprise conference is pretty good, I think. Thanks, Hank.
Thanks. Yeah, it's a great conference to talk to. I actually spoke at it last year as well. The next one is we have a date for May 1st to the 3rd is NGConf. I'm assuming most of you in this room know what that is. If you get a chance to go, please go. I think it's an awesome conference to attend. Matt here is attending that conference, so hopefully we'll get some live stuff feeds from him, right? Okay. Okay. Also, the Women of Code, GDG Atlanta wanted me to extend an invitation to the I/O Extended 2019 Atlanta. I guess this is the Google announcements for all the new product lines. I know it kind of conflicts a little bit with the NGConf, but I think it'll be interesting to attend. It'll be at Big Nerd Ranch. Refactor Tech is another conference you'll want to keep on your radar. It's a local conference. It was called We Rise last year. It's an awesome conference. It's about inclusivity and diversity in technology. So there's a lot of great speakers there. Tickets are still available. I think there might still be a discount for early birds. Just go onto the website and all that information there is for you. Also, I'm going to let Sean here speak on this particular charity event.
I'm going to do my, hey guys, I'm going to do my best to not use my notes here, but I'm probably going to have to do that because, yeah, I'm talking in front of a group. So at any rate, I'm Sean Fitzgerald, Senior Database Engineer here at Kabbage. One of the things that I'm also responsible for is being a Spin for Kids ambassador for Camp Twin Lakes. So I don't know if any of you have heard of Camp Twin Lakes before. If you have, yeah, give me, raise your hand, because that's pretty amazing. Yeah, good stuff. Okay, we've got a few people. Hey, there you go. And then we've got Spin for Kids. Anybody done the ride? Anybody heard about the ride? No. Okay, that's disappointing, but that's okay. So let me tell you a little bit about the camp. So Camp Twin Lakes, it's a year-round camp. It's a fully accessible camp. And it provides kids with challenges a full and rich camping experience, right? So I don't know, I grew up going to summer camp, really enjoyed it as a kid, found it very fulfilling. This extends that to kids with challenges. It's just an opportunity. It's a great opportunity for those kids to get out there and just be kids, right? So what is Spin for Kids? Well, this is an annual cycling event and one of the primary fundraisers for the camp, right? So the route is located in Rutledge, Georgia. It starts and ends at the camp, and there's an amazing after party that happens all day. A lot of fun. You can ride your bike there. A lot of fun to spend with your family if you just want to come out and hang out. It's a great way to give back to the camp, give back to the community. Why is this such a big thing? Now, I mentioned that Spin for Kids is one of the main fundraisers for the camp. So last year, 2018, we raised over $461,000 to send kids to camp. That's significant. It all goes back directly into the camp. And this year, what we're trying to do is raise enough funds so that we can send an additional 3,500 kids to camp. That's $500 a pop, send a kid to camp 1 week. So that's a lot of money that we got to raise. The way that we're trying to do that is we're just trying to bring basically more riders to the event, but also more families. Because once you get to the camp, you'll see how impactful it is on a day-to-day basis for these kids, for the families involved. It's a really great way to give back to the camp, give back to the community. That's about it. Super event. Really stoked if you guys have any interest in it. I've got a clipboard that I'll have out front here. I'll stick around for this as well, so you can just talk to me directly. Any questions? Really appreciate your time, and enjoy the rest of the show.
Thanks, John. That's a great event. So you have a team already set up?
Well, so we are setting up a team. Kabbage has kind of decided to bring the team down. Like, we had a team at one point, bring the team back now. So we're trying to increase the ridership there. We're
Okay.
also trying to extend that outside of the group, though, so that riders from other organizations can get involved. Still trying to figure out what that looks like overall, but we're looking at more of a technology, Atlanta technology sort of a ridership.
Okay, you should talk to me a little bit later. I can introduce you to the other ones, the other organizers. Okay.
Cool, thanks.
Anybody have any announcements, any events, any job opportunities?
Yeah, hey, I'm co-founder of a company called Real Theory. We're based out of Georgia Tech. We use artificial intelligence to optimize applications in the cloud. We're hiring front-end developers. Our stack is built 100% on microservices, Docker, Kubernetes, and Angular and D3 on the front end. Team's about 16. We only hire people that have full-time jobs and can commit to 5 to 10 I brought one of my senior devs, Caleb, who is Georgia born and raised. We intend to be opening a space down in Pond City Market by the end of the summer. We look to be hiring between 15 and 20 folks, including not only dev and technical leadership, but also agile delivery and sales within that space. And you'll probably be seeing a fair bit more of me over the next few months as I start to get to know each and every one. Thank you. I'm coming for the barbecue.
It's been a good barbecue, so yeah.
The warmth. It's 32 degrees at home. It's 70 something out there right now. Love it. Thank you very much.
Thank you, Gene. Yeah. Great. Anyone else? Okay, one more. Okay. Uh-huh. Okay. Okay, great. Maybe afterwards, you guys come see me, and we'll make sure that those positions get posted on the job board. We do have a Meetup Job Board. A lot of people aren't aware it's there. It's kind of hidden now since Meetup redesigned their UI to be mobile friendly, which isn't really friendly, but it's there. So let everyone know. Was there somebody else that I thought I saw raise their hand? No? Okay. Then we'll get on to our main event here. Lucas, where's Lucas at? Corey. There you are. Oh, Corey, I'm sorry.
That's fine.
Is your last name Lucas?
Lucas is my last name.
Oh, that's what it was. Okay. Awesome. You got yours plugged in?
Yeah.
Okay. Awesome.
You go under or around? You're not going under. Not full tank now. My podium? You like my podium? Okay, everybody hear me? Yes. Microphone's working? Okay, good. Change that one off. All right. Okay, so I'm here to talk about Docker and Kubernetes, and a little bit about how you can use that to work with your Angular projects. So first of all, a little bit about me. Principal engineer here at Kabbage. So in general, like this is our office, so you can kind of see how we do things around here. We're pretty laid back, it's a relatively large company at this point, but we're still very startup in feel. I've been here almost 6 years now, so it's a great place to work. We're hiring for lots of different positions. So if you're interested at all, definitely see any of the people here. A lot of us don't have name tags on, but some of us do. There's a bunch of us here who work here. David's our CTO, so lots of people to talk to if you're interested in anything, or you can also apply on our website. If you're looking for me, you can find me on Twitter, Corey F. Lucas. It's the only social media I use at all. I don't use it very much. Email, my personal email or my work email, whichever. So yeah, if you're interested in any of this afterwards, either grab me after the talk or hit me up on email. So, Docker. Oh, hold on, I forgot. Got my slides printed because I got presenter notes. Okay, real quick survey. Who here knows what Docker is? Okay, good. Almost everybody. Okay, who's using it for local development? Okay, and who's using it in production? Okay, good. So this will not be too terribly boring. Okay, so let's start off with what is Docker? Okay, so Docker is a tool for running containers. So that doesn't necessarily tell you a whole lot. But really the idea is it lets you take your application code and you bundle it up into what's called a container image, and then you can run it. So the reasons you want to do this is, who's ever run into a situation where you do a code change and it doesn't work somewhere else, and you say, it works on my machine? Who's done that, right? So a lot of what this is about is avoiding that problem altogether because you have a consistent environment to run your application in. So what's a container? So the things that a container gets you, you get process isolation. So who here is familiar with like the concept of VMs in general, virtual machines? Okay, so it's kind of like virtual machines, except you got a lot less of the overhead of virtual machines. With every virtual machine, you're running an entire copy of the operating system inside of another system, generally on top of another operating system. So with containers, you bypass a lot of that because you're sharing the underlying operating system kernel. So you're not running completely isolated, but it's essentially built on top of a bunch of tools built into Linux that give you process isolation while still allowing share part of the operating system. So because of that, you got a lot faster boot times, you have lower overhead, so you can generally run more containers on the same hardware than you would if you were running VMs. And yes, mostly it eliminates the runs on my machine. Doesn't completely eliminate that. Obviously, like in your test environment, in your production environment, you have different configurations, so it's not going to eliminate problems related to that, but it will eliminate problems like, oh, I was using this library and it, for some reason, is not installed in production, or our test environment's running node 8 and our production's running node 10, stuff like that. So real quick, another thing that you have with Docker is volumes. Just going to talk about this because it kind of ties into some other stuff later. So one of the things that you have to realize with containers in general is when you boot up a container, you're booted your application and you have file system that you can access. But anything that you generally write to that file system will go away as soon as you restart that container. So volumes are a way to give yourself persistent storage. So the idea is I have a container, it attaches to a volume, and then I can restart that container and reattach to the same volume, and all my stuff that I wrote to disk is still there. Now, like, you don't generally want to use these except for very special cases. Generally with containers, the idea is your application is misbehaving, you just kill the container and start another one, and it's okay. They're useful for a couple of other things, though. So one of the things that we personally do at Kabbage is we use them in our Kubernetes setup to actually share data between two containers. So a common use case for this would be, I'm going to run a container, and it's going to do something and generate some sort of config file, and then another application running in another container will read that configuration file. So there's a bunch of different use cases for doing that. One thing to realize is they're not necessarily persisting to disk either. So especially in like the Kubernetes world, your volumes, they may be just in memory, they may be disk on the actual host, they might be, if you're running in the cloud, kind of dynamically provisioned storage, it might be an NFS mount, something like that. So Dockerizing your app, what's involved? It's not really as bad as it sounds. Really the steps are you create a Docker file. A Docker file is essentially a set of steps, repeatable steps to actually build your Docker image. So you copy file in, you run commands, set environment variables, things like that. You use the Docker CLI to build the image. So you run Docker build. You use the Docker CLI generally to run your app, Docker run. You use Docker CLI to publish that image. So use Docker push. You can either publish to, there's kind of a public centralized Docker repository called Docker Hub, or if you're doing work for like an actual company, so like for Kabbage we have Artifactory, and we publish to our own private Artifactory repository for our private images. So let's go into a quick demo here. So can everybody, hold on, let me close that. So what I've got here is I've got a relatively simple Angular app. So it's got an Angular front end. It's basically the Hall of Heroes app from the tutorial on Angular. There's a server-side component that's using Nest.js, which is also going to serve our actual Angular content. And it's also an API on top of a Postgres database. So inside our client stuff we have, they're actually two separate packages, so they each have their own package JSON. But yeah, you have just the traditional Angular app, source app. It's just got basically everything except I think the messages component of the Heroes app. Our actual server stuff is also pretty similar or simple. We have a database module. We're setting up, trying to think of the name of the library, type ORM to connect to the database. And then we have a controller and some services to query for the database. So pretty straightforward. So let's see what it would take to kind of run this outside of Docker. So we're going to go into, before we do anything, I'm going to kind of cheat. So one of the things I mentioned is this has a database component to it, right? So historically, if you had a database that you needed for your local application development, you either use a shared dev server, which the problem is everybody's sharing it, so everybody's stepping on all over your stuff, or you installed and ran Postgres on your laptop, which is gross because you need to remember to stop it, you need to remember to update it, everybody's running 10 different versions of it. We're going to use Docker to actually start our database, just in the background, if I can do the commands in the right order. So now I've got Docker running, Postgres running in Docker. We'll worry about that a little bit more in a second. We're going to go into our node module here, or our client, and we're going to run npm install. And we're going to wait for that to run because all right. And then we're going to run, so this app was built with Angular CLI, so we have some of the built-in NPM scripts. So we're going to run build instead of serve here, and we're just going to watch that. Someone's calling me. One second. And in another terminal here, I'm going to go and we're going to go into our server component and npm install again. And then we're going to start our server here. And so the way this is set up, it's running nodemon to actually monitor for changes and things like that. So this is kind of how you would do normal local dev with this. And it's putting all of our files where it's, the front end bit is putting all of our files where the back end bit can get to them. So we've got kind of our NG Heroes app here. Let me make that a little bigger. So we've got a dashboard. There's nothing in the database yet. We can go to the Heroes page and we can add a hero, Batman. And now we have our Batman hero, all that good stuff, right? So that's how we would run this app locally. Kind of showed you the commands there. Look at how we would put this in Docker. So we have one Docker file for this whole thing. Collapse that. Okay, so we're going to start this with a from line. So all your Docker files are going to start with a from line. You're saying, I'm going to start from this image. And in this case, we're doing multi-stage Docker builds. I'll kind of explain a little bit about what that is later. It's a little bit more advanced, but in reality, at this point, if you're doing Docker builds, you should be using multi-stage. It makes everything so much easier. So we're just going to give this stage of our build a label. So we're going to call it build. So real quick, what does this mean? So we're running a node image. This comes from the actual node, 10.15. That's the version we're running. Alpine is because this is an Alpine Linux. Anybody here know what Alpine Linux is? So if you're running in containers, one of the things you generally try and do is keep your container as small as possible. So if you're running a traditional Linux distribution like Debian, it's relatively big, mostly because of a thing called libc. Alpine doesn't use that, it uses some other stuff, so it's just teeny tiny compared to a Debian image. So in general, if you can make it work in Alpine, that's kind of your best bet. but you can't always make stuff work in it, then generally you either go to like Ubuntu or you go to Debian, something like that. So first thing we're going to do. So this is kind of a little bit more advanced way than you would build your Docker files, but this is following some good best practices here. So the first thing we're going to do is we're going to copy in our package JSON files for the client application. And then we're going to run npm install. And then we're going to do the same thing for our server application. So what you could actually do is just copy in all of your code into the image first, and then run those steps. The reason you would do these two steps first separately like this and only pull those in is when you build your Docker image, it's going to cache all of these steps. And it's pretty smart about invalidating that cache. So because we only pulled in the package JSON files, so we're going to get our package JSON and our package lock JSON, it won't invalidate the cache for those two steps unless we change those two files. And what is the slowest part of our build? It's restoring all of our package with npm install. So this means that unless I change my dependencies, I don't need to run those two steps again. So that helps speed up our builds. So once we've done that, we're going to copy in the rest of the code. It's going to overwrite that package JSON. That's fine. Doesn't matter. And then we're going to run npm build --prod. We're going to go into our server and run npm build. So at this point, both of those have a dist folder. And then we're going to start a brand new image here. So we're going to start again from node 1015 Alpine as node modules. And what we're going to do is we're going to pull in the package JSON again, and we're going to do an npm install production, because on the server side, our Nest application, the dist folder doesn't have the dependencies it actually needs. So it's got the normal package install has got all our dev dependencies. So this gives us just the stuff we need for prod. And then we're going to start over one more time. And now kind of the magic of multi-stage builds. And what we're actually going to do is say, from this build step we did earlier, so from that image we already kind of pre-computed, we're going to copy the dist folder into our new image. And then we're also going to copy the node modules folder from our node modules images we had. So all we have at this point is we have a bare Alpine image with node installed and the code needed to run our application. So it's as small as possible. So you don't have any, like the way you used to do a lot of this stuff is you would essentially run all those commands with and in between them, ampersand, so that it wouldn't, Docker will make a layer in your image for every command you run. But if you chain them all together and then you cleaned up all the temporary files in between them and you ampersanded them all together so it was kind of one command, then you didn't have that problem. This just makes it so you can actually read the file, because what you ended up with before is I have one run command and I have 15 completely random things all stuck together. So the last thing we're going to do is we're going to set our work directory to where our server code is, and then we're going to set our entry point. So this is the command that was going to run when our container starts by default. So we're just going to run node dist main.js. So that's our server code, right? So what do we do with this? So we're going to build this image. So let me just stop all the stuff I got running here. So we're going to go back to our root here, and building this is pretty straightforward. Oh, before I get into this, real quick, if you want to run Docker on your laptop, if you're running a Mac or a Windows, this is really easy. There's Docker for Mac, Docker for Windows from actual Docker. It's kind of the easiest way to get started. The weird thing is Docker relies on things built into the Linux kernel. So on Mac and on Windows, it runs in a VM kind of behind the scenes. You don't notice any of that. If you're running Linux, I'm sorry, it's a little bit more complicated to actually get it set up and run, and so you can run it as a normal user and not use sudo on everything. But generally, if you're running Linux, I'm going to assume that you can figure it out. So we're going to run Docker build to build our image here. So we're going to actually tag this kind of right off the bat. So we're going to tag this as Corey F. Lucas, which is, well, let me do this. Corey F. Lucas, which is my Docker Hub username, because that's my name. 1.0. So this is our version 1.0. And then we're going to say we want to build in the current directory. And so this is going to run through those steps. shouldn't normally actually run that fast, but I guess I ran this before. Well, let's do this. See if that builds slower. It's not going to build slower. So normally that would build slower. Like I said, Docker's good about caching everything. So you can see you did this use cache on all these steps here. So normally that command would take a little while because it's going to run your npm install. So what are we going to do from here? So we've got our Postgres database running. So I'm going to actually run that image now. This command's going to look kind of scary. So we do a Docker run. RRM means clean this up after I'm done. One of the things you run into is you have a bunch of old dead containers on your machine. We're going to set an environment variable so that this knows how to talk to our database. We're going to expose a port 3000, because that's what our app runs on. And we're going to kind of stick this into the network I used to start that Postgres database. And don't worry, I'm going to show you a much less gross way of starting this later. So, got our application running. This is just going to be the standard output of your container here. So if we go back to this, we have our app running again, but now it's running in Docker rather than outside. So now that we've got that working and we know our container works, and I think it's not going to die nicely, we're going to kill it. We're going to Docker push it, which is going to push it out to Docker Hub by default. So if we go to Docker Hub here, I already made this repository, but you wouldn't have to do that ahead of time. It would just do it by itself. But you can see there was no tags, and now there should be a 1.0 tag, assuming this worked. Yep, so we have our 1.0 tag that we just built. So yeah, that's kind of our real intro here to Docker. Anybody have any questions on that real quick? Anybody? Okay. So one of the things we did in that was when we built our Angular app, we built that with the prod flag. So just real quick, why you should build with the prod flag always if you're going to deploy this anywhere. So this is if you build without the prod flag. So you have most of the same files with or without it, but the big thing is if you look at this vendor.js, that's 3.8 megabytes. That's kind of big, especially if you're on mobile. That goes completely away when we build with the prod flag. It kind of gets smushed in with the main JS file. So you'll see that the main JS file goes from being 37K to 316, but most every other file gets smaller and we get rid of this giant file. So if you're ever building Docker images, make sure you build with the prod flag. It does mean that like by default it's going to use your Angular prod configuration. We'll talk a little bit about that in a second, but don't run in production without that flag. So some best practices with Docker in general. Don't write to disk unless it's in a volume. Anything you write inside your container to the root volume goes away as soon as you restart your container. Part of the benefit of running in containers is I can restart the application and it doesn't matter. So logging, generally you log to disk in a normal environment. The way I would recommend you log is to log to so most everything that's going to run Docker at a higher level is going to capture the standard out for you. If you're running in Kubernetes, it does this. Makes dealing with logs really easy, both as a producer of logs or something consuming it to ship them to, say, a log aggregation system. Run the same image in all environments. You should not be building an image for your test environment and a separate image for your production environment. You should not rebuild in between. You lose a lot of the benefits. I am getting the consistent environment if you rebuild that image. So how do you do that? So you need to externalize any sort of configuration that you're going to use when you run this app, and externalize it from your application. Generally, the two different ways to do this is either you use environment variables or you use a configuration file that you're going to put in a volume. Environment variables is generally a little bit easier. Volume is a little bit more flexible in terms of like it can be a JSON file. It can change as configuration changes, things like that. Keep your images small. It speeds up your deployments. It speeds up pushes. So just avoid unnecessary files. Use multi-stage builds. And run only a single application per container. Even at Kabbage, we have dealt with this in the past where we have containers where we run an Angular app and we run Nginx to serve that application. So the problem when you're running in that kind of setup is what you generally end up running is you run, say, supervisor D to watch those two processes and make sure they stay up, right? If you're running in any sort of container orchestration system, that's going to take care of that for you. So it's just one less thing you have to worry about if you can run separate containers per application. That also helps keep everything smaller. So using Docker for development. So the biggest thing with this is you'll probably use a tool called Docker Compose. So you get some of the benefits you get. So I will say, like, the way I prefer to run apps locally with Docker, do not run the same image I'm going to run in production, which means that you're throwing some of the stuff out, right? But you can still ensure I'm running the same version of Node, that kind of thing. And it also means that your development setup experience is a lot easier. And it makes it a lot easier to give everybody kind of their own fully built out environment. Everybody gets their own database, that kind of thing. And generally, if you do it right, it's pretty easy to get somebody up and running. So we'll do a quick demo of that. So if we go in here, we have our Docker Compose file. Docker Compose ships with basically all the versions of Docker, so you don't need to install anything extra. It's YAML. All the things related to Docker are YAML now, so you're going to learn to hate YAML, but it's a thing. So this is the most straightforward way to use Docker Compose for this. So we're going to say, hey, I have a service called app, which is going to be our actually running application. We're going to say you build it by building the current directory. We're going to expose port 3000, which was in one of our command line args. And we're going to set some environment variables so it knows how to talk to our database. In this case, most of these are the same as the defaults I've hard-coded into the application, so we don't really need to set them. But this is convenient so that you don't necessarily have to have defaults for how you're connecting to your database or something like that. A good example of how you can inject configuration into your app at runtime without having different images. And then we're going to tell it to run a Postgres image. So we're going to run Postgres 10, and we're going to expose the ports for it. This is mostly because I was running the app outside of Docker before. But this can also be convenient. This is exposing the port to my local machine. So if you're running some sort of tool that you can connect to a SQL database, you can still connect to this database even though it's running inside of Docker. So what would it look like to actually use this? All we would need to do, make sure I'm in the right directory, is run Docker Compose up. And that's going to make sure our containers start. If I hadn't already built that image, it would have rebuilt it for me. But then I can go back, and my app is running again still. So I'm just going to give you kind of a quick glance at, so the problem with running it this way is I'm rebuilding that image from scratch every time. So if, like, I'm doing a lot of stuff to make that build as fast as possible, but as we all know, if you're doing traditional Angular dev, like you're running with live reload and things like that, so I make a change to a file, I immediately see it in my browser. If I have to rebuild the container every time, that obviously slows down that dev experience, so that's not great. So this is kind of some somewhat wonky hacks around it, but this is kind of similar to what I would generally recommend for how you use Docker Compose locally. So The biggest difference here is we're going to start with an image rather than building our container. We're going to start with that same node image that we use to build our normal containers. And the other thing you'll see is we're using a volume here to mount the current directory into the image. So we're going to mount the current directory into the image as /app. And then I'm going to run an npm script inside of that. Everything else is the same. I have kind of a stub npm package JSON here at the root. And what I'm going to do is I'm going to use a tool called npm run all to start basically the client and the server at the same time, but it's going to rebuild those as soon as we start the container. So the nice thing is now I have all of my code mounted inside the container. It can see any change I make to my disk immediately, and it's watching those for changes. So in reality, like, you could probably get this set up so all your live reload and all that stuff works inside of here, but you're still getting the benefit of, like, in reality, you don't need Node installed on your machine. It doesn't matter. And you can run different versions of Node. If you have apps that need an old version of Node, it doesn't matter. It doesn't conflict with what you have on your local laptop. So, any questions? Cool. All right. So, Kubernetes. So, you saw you can run a container with Docker run, right? That's great. That's a good, reasonable way to get started running stuff with Docker. It's great for local dev. Kind of a pain to manage in production, right? You don't have any good way to automate all those deployments. So, what is Kubernetes? Kubernetes is a container orchestration system. So, it runs our containers. It makes sure they're healthy for us. It restarts them if they become unhealthy. If they just crash, it'll start you a new copy. So you don't really care. Again, why you don't want to write to disk in your container, you want your containers to just be able to restart. The other thing it does is it abstracts the underlying hardware that you're running Kubernetes on top of away from you. You don't care how many servers you have, how fast they are, how much RAM they are. Kubernetes will worry about that. You don't worry about that. It has service discovery. So a lot of what people are doing now in containers is microservices, right? So if I have microservices, I have a whole bunch of services. Most of those services need to talk to each other. Well, how do they talk to each other? You don't want to necessarily hard code URLs for service A needs to talk to service B. You can rely on Kubernetes. What you do is you create services which match to certain containers that are running, and then from another container that needs to talk to that service, you can resolve it via DNS. So it just kind of works. So instead of talking to b.kabbage.com, you just talk to B. And wherever B is, it's just going to resolve to something else inside the cluster. Configuration management and secrets management. So Kubernetes has tools to let you push your configuration into Kubernetes or your secrets into Kubernetes, and then inject that into your containers for you via environment variables or volume mounts or command line parameters, stuff like that. One quick note about secrets. Secrets, not really so great about storing secrets. By default, I don't think they're actually encrypted in the normal version of production or of Kubernetes right now. The biggest thing with secrets versus configuration in Kubernetes is they're two separate resources, so there's different ACLs around them, but just something to be aware of. Secrets aren't necessarily encrypted, so they're not super secret, but they're still convenient. So the parts of our Kubernetes cluster, first thing you have nodes. Nodes are the thing running your cluster, the underlying hosts. You got two types, masters and workers. Your masters kind of run the guts of Kubernetes. The interesting thing is most of that still runs in Docker. And then you have your worker that runs mostly just your apps, generally also a couple of components of the actual cluster. You can attach labels to these so that you can, if you have some workers with, say, high-end GPUs and you want to run machine learning on them or something like that, you might tag them with certain labels so that later when you're running your code, you would say, hey, I want to run on the machines with the high-end GPUs. For the most part, you ignore these. So like they're there. You kind of need to know they're there, but you don't interact with these very much. The thing you interact with mostly, kind of the building block of everything is pods. So a pod is one or more containers. There's interesting reasons why you want more than one container in these. This is really convenient for setups like I mentioned earlier, where we run Nginx to serve a Node.js app. If you wanted to run something like that, but run them in two separate containers, you run them in the same pod. The pod acts kind of like a machine in that if I talk to another container inside that pod, I can talk to it as over localhost. You show up as having the same IP to everybody else. You can technically see other processes within that same pod if you really want to. So you can kind of break some of that isolation. They're guaranteed to run on a single node in the cluster. Building block of all the other stuff we're about to talk about, and this is generally your unit of scale in Kubernetes. Okay, so you don't generally make pods. You don't generally make these either, but a replica set is a layer on top of pods that essentially just guarantees that I have X number of copies of a pod running. It does this by matching labels that you create on the pod. So it says, hey, I'm looking for pods that look like they say that they're app X, and I see that there's 3 pods labeled app X, and I'm supposed to have 4. So I'm going to go ahead and I'm going to make another one. So, okay, deployments. Deployments is the thing you actually will use. So deployments are great. Deployments manage replica sets for you. So deployments, you basically, you give it a pod definition. You say, I want X number of copies of this, just like a replica set. But the cool thing that they do is they also let you roll out changes in a controlled way. So by default, they do rolling deployments. So if I make a change, it doesn't just replace all of my running stuff at once. It replaces one. And make sure that starts. If that doesn't start, it just says, you need to go look at that. I'm not going to keep doing stuff. But if it works, then it'll keep rolling it out. If it didn't notice that it was broken and you notice it's broken, you can roll it back. You can undo any sort of change to like what image you're running, any environment variable changes you did, any of that stuff. So deployments are great. So services, this is for our service discovery. So a service matches to pods based on labels, just like all the other stuff. So you would make a set of pods with a label of app equals X. You make a service that says, hey, I pointed all the pods that have app equals X. And then you can give that a name, and then any other containers that want to access that service, look it up by DNS. One of the cool things you can also do with this is you can tell it that, hey, I want you to go ahead and I want you to make me a load balancer. If you're running on AWS, it'll make you an Elastic load balancer. You're running on GCE, it'll make you whatever their equivalent of that is, that kind of thing. So super convenient for that. So let's do a quick demo of running the same app on Kubernetes. So, like I said, you're going to learn to love YAML if you learn a lot of Docker stuff. So, real quick, I'm going to go through this super quick because this is relatively complicated and it doesn't really matter. This is the Kubernetes config for our database. We're going to make a service so our app doesn't need to know the host name of the database. We're going to call it ngheroesdb. We're going to make a secret. So this has the username and password of our database. They're just base64 encoded. That's not encrypted. It's not secret or anything like that. Don't try and decode it. It's nothing fancy. And then we're going to make what's called a stateful set, which makes sense for stateful workloads like a database. Yeah, there's not much else in there that matters. So we're going to go ahead and get this started. So the tool that you use to interact with Kubernetes is kubectl. Make sure it's still working. This is running in a real Kubernetes cluster hosted in DigitalOcean. I just spun this up last night. If you're looking for a real Kubernetes cluster to play around with, this is great because it's super cheap. It's like $10 a month for a single node, which is super cheap compared to we run most of our Kubernetes in production on Amazon EKS, and I think a cluster by itself with no host to do any work is like $140. So $10 is a great deal. So first thing we're going to do is we're going to go ahead and we're going to apply that configuration. And that's going to make some stuff, and we don't really care too much about what that is. So let's go to the stuff that we do care about. So our deployment, like I said, deployment's the main thing you're going to generally interact with. Every Kubernetes YAML file you'll ever look at is going to start with an API version and a kind that tells it essentially what API it needs to interact with. The really old stuff is all just V1. The rest of the stuff has what's called API groups. So apps is where deployments is. If you're using real new stuff in Kubernetes, it'll either be like V1 beta or V1 alpha, stuff like that. They roll everything out through different versions. So you get the production version comes with a bunch of alpha and beta stuff built in. Generally, they're pretty stable, but kind of buyer beware. We're going to set some metadata about our deployment. So we're going to give it a name and a label here. For the deployment, the labels don't really matter a whole lot. Best practice to label stuff, though, just so that your monitoring tools will pick this up, anything like that. So now we get into the guts. So our spec for our deployment. Replicas. How many of these do we want? We want to run 2 copies. So bare minimum here, just want some resiliency. The selector here tells it what it's going to look for in terms of what pods it's managing. It's worth noting here that if I created this deployment and I had 2 pods already running with this label on it already, it's going to do nothing because it's going to be like, oh, I'm already at capacity, I'm good. So just something to be aware of. Then we have the template. This defines our pod. So we have, we're going to set our label so that it must match this. Kubernetes will yell at you if those don't match, which is probably good so it doesn't make like an infinite number of containers for you. And then within our pod, we have our containers. So we're going to start our ng heroes container here. Let me fix that. We're going to expose our port 3000. One thing that's cool here is you can give it a name. So most things run on kind of weird ports when you're doing local dev. You can't expose lower ports without running as root and things like that. I don't really want to muck with that, but I can just give it a name, and then everything else can refer to this name instead of having to know that, oh, this runs on port 3000, and this other thing, it runs on 8080. We're going to set up our DB host. We're going to point to the service we made for the database. We're going to set our DB name. That's just hard-coded. And then we're going to use that secret to inject our username and our password. So we say, you see, we have a DB username and DB password environment variables, and we're saying, hey, get the value from this secret. So you can do the same thing with a thing called a config map, which is how you do just traditional config that's not secret. So we wanted to actually get that set up in the cluster. We do kind of the same deal. We run an apply on our deployment. That's going to make our deployment. That's great. So now we can do kubectl get pods. So we can see the pods that we're running, right? Let me do this. So we've got 3 pods running. Oh, one of them's broken. Well, so there's our database. Hold on, let me figure out what I did wrong. Did I actually push it? I know I pushed it. ng heroes 1.0. Spelled it wrong. Let's do that again. Let's do an apply again. So the cool thing with apply is it'll do differential changes based on what you changed in your YAML file. Yep. So now we've got one. So that's our old dead container. Here's our new stuff that's running because it's spelled right. So we got 2 copies running. That's great. We have an app running. What do I do with that? That's not very helpful by itself, right? So let's put that on the internet. So we're going to make a service. Call it ng heroes. Same kind of deal. Important thing here, type load balancer. Tells it, hey, make me a load balancer. What that does varies based on where you're running your cluster. I'm running in DigitalOcean. It's going to make me a DigitalOcean load balancer. And we're exposing port 80. And like I said, you can point. So target port is what port it's going to point to on the pods. So we just use that name again, HTTP. Don't need to know that's 3000. Don't care. It's great. Selector app ng heroes. So that tells it what containers to point at. So in reality, there's no reason this service has to run at multiple copies of the same container. If I made 2 pods with completely different container images, but I gave them the same selectors, you can put them both behind this. There's interesting things you could do with that if you wanted to do some sort of A/B test or something like that. There's generally better tools to do that where you could have more control over it versus just this is going to be kind of random, but good to know it's there. I totally already applied that because making a load balancer takes a long time in DigitalOcean for some reason. So let's go get our service. So we have our NG Heroes service here. And you'll see it's got a cluster IP, which is the IP of it inside the cluster, and then you have our external IP, which is our IP on the internet. So I already have that loaded up here. And we have our app running in Kubernetes. And I can add Superman. And I have that there. So we talked about how deployments make it easy to do changes in a somewhat controlled fashion. So let's go ahead and we'll do that real quick. So we're going to go to our client here. And we're going to go to the app component, and we're just going to change our title. So it's NG Heroes, exclamation point, because we're excited. And then we're going to build our image again. But this time we're going to call it Corey F. Lucas / NG Heroes 1.1. Like I said, so you see the Docker cache stuff kind of in progress here. We didn't run an npm again. Saved us lots of time. And then we're going to push this image. And then, so you can see here it says NG Heroes, right? So let's go ahead and we're going to go and edit our deployment. And we're going to change the tag that we're pointed to 1.1. Like I said, if you use kubectl apply, it's going to do a differential update for you. So we're just going to apply that. And instead of normally it would have said created, it says configured. So if we go look now, you'll see we've got our old containers, which are now shutting down, and we've got 2 new ones, which are started. So kind of the magic around how this works. I said deployment manages replica sets. If we pull the replica sets for the NG Heroes, we can see there's actually 3, because I messed up the first time, and then we did it right one time, and then we made the new one. So you can see what it actually does is it scales up the number of pods it's expecting within each replica set, and then it scales down the old ones, and that's how it does rolling deployments. So if we go back here, we now have our nice exclamation point. So I said you can do rollbacks with this, right? So let's look at the rollout history for our deployment. So like I said, we got 3 replica sets because we did 3 deployments. We have 3 revisions in our rollout history. So let's say somebody in marketing says we don't like that exclamation point. So we're going to undo our rollout, which is going to roll us back to the version before that. So if we go back to our replica sets now, you can kind of see it's ramping this one up and ramping our old one back down. And then we're done with that. We go look at our pods. We have 2 that are shutting down and 2 of our old ones burning back up. And our exclamation point is gone. So any questions? Matt.
So this is a ton of stuff, a ton of information. Let's say you're just starting out, you don't care about load balancing yet, you're not trying to manage a prod instance for a large company. What are the core concepts you need to know about Docker to get started actually using this and learn how to do this?
Yeah, I think the biggest thing so the biggest benefit you get out of Docker is this repeatable stuff, right? It's all about, I run this thing and it's exactly the same every time. So a lot of it's kind of those best practices I mentioned, like keep your images small. You need to make sure you're, generally what Docker is best at is not things like database servers. So I ran a database server in Kubernetes, it's great. If I go and kill it, it'll be gone for a little while and it'll come back and it'll still have all its disk and stuff like that. But where Docker shines is your stateless apps, your traditional microservices, things that it's okay if I kill one of these and it comes back. So that's a lot of what you need to keep in mind is when you're developing anything you're going to put in Docker, you need to build it in such a way that it doesn't matter if I restart this in production. Like, yeah, maybe there's like a blip because it can't handle traffic for a second, but it shouldn't require that when it starts up, somebody needs to go and poke it and do something manually to it. A lot of this is really just about automating your workflow. Other things, start using it for development first, then work your way into prod. Like, it's a big change in mindset from I copy file, like I build with Node on my machine and I copy it into production. But like every incremental bit of automation buys you a little bit until you get to a point where everything is fully automated. So for example, the stuff that we are running at Kabbage right now in Kubernetes is kind of a brand new product. There's not a lot of users on it, so it's relatively low risk right now. But what we did when we started that project is we set out to have fully automated deploys. So what we actually do with that is if you make a change to any of the services or the application that runs, and you check those into Git, we check out that branch, we run the unit test against it, your standard stuff, and then we actually create what's called a namespace in Kubernetes, which is kind of an isolation unit. We create a stub environment for it, we deploy that code to that environment, and we run tests against that application running in the same container we would deploy to production. And if those tests pass, then you can merge a pull request. And if you merge that pull request, then we do the exact same thing again just to be safe. And then we put it out into a real environment, run more tests against it. If those pass, they go to production. Nobody touches it. So that means, with that project, I think in the month of January, we did something like 120 deployments to production. All of those deployments are super tiny, so they're relatively low risk. There's not a lot of people using the system, so it's also low risk. But that's kind of like, that's the ideal state. That's your end goal, is just automating your workflow.
Did you say keep your containers one per application, so in production you would separate your servers from your client?
So yeah, so it kind of depends. So in the case of an Angular app, right, you need something to serve your HTML to the browser, right? In my example app, I'm using my node layer to actually do that. If you weren't doing that and you were using something like Nginx to do it, then yes, I would say run those in 2 separate containers. Really what that comes down to, and here I can actually just show you this. So I've got 2 pods running my NG heroes, right? If I just say delete one of them because I'm a jerk. Kubernetes is like, hey, jerk, I'm just going to make another one, right? So if one of those crashes, it just makes another one for you. So the reason you want to run a single app is you have less complexity in each container, and you're not worrying about keeping those up anymore. You let Kubernetes deal with that for you. There's alternatives to Kubernetes, by the way. There's the 2 big ones would be Docker Swarm, which kind of ships with Docker Enterprise, and then there's also Nomad from HashiCorp. Both of those are a little bit simpler, not nearly as popular. The nice thing with Kubernetes is partly it does a lot of stuff. They're kind of at a point now where they've said, like, we're not really adding much more core stuff to it. But just having the large community around it means, like, there's more blogs around it, there's more documentation, there's more tools built specifically for it. But any of those tools are really great depending on what your workflow is and what tools you're also using. Yep.
Can you, do you have an example? Would it take you long to show like an example? Because I'm kind of going through that right now, and I wanted to kind of see how the connected things together.
So I don't have an example of that. We don't actually do that anywhere with networking local hosts like that. What we do have is we have several applications we actually run. Actually, no, we do have some stuff with that. I can show you some examples afterwards. The thing we actually use with that is we use a distributed tracing system for some of our newer code called Jaeger. So distributed tracing, the idea is kind of like logging and instrumentation on steroids. So you get essentially a trace for every request, and you have what's called spans within that, which would generally be like some piece of work, and you can view that, and the idea is, I have a request, it took 20 seconds, which is obviously terribly slow, right? And I want to see, why was that slow? So historically, Kabbage is like, I don't know, it's probably the database. I don't know, it's probably that. With this, the idea is you can instrument your code such a way that you can say like, okay, that query ran 3 database queries. This one right here, that one took 12 seconds. That's our problem. So the tool that we use for that, you run your application, and then you run what's commonly referred to as a sidecar container in Kubernetes next to it, and our application sends localhost UDP traffic to this sidecar, which actually sends it to the main collection service. The reason you want to do this is UDP is super lightweight, but there's no guarantees on it ever getting anywhere. So sending it to this localhost, you get a lot more of those guarantees kind of for free. So you just get the lightweight network traffic. It offloads, oh man, the collection service is down for a second. I'm going to bundle these metrics for a little while. I'll hold on to them, and I'll send it when it comes back without our application needing to know about it. The other thing that we do run side by side, we run as a sidecar, is a thing that we kind of built ourselves actually to interface with a tool from HashiCorp called Vault, which is a much better thing for actually managing secrets. But it's relatively complicated to talk to. So what we actually do is we run a sidecar container that all it does is it talks to Vault. It fetches secrets from it, it renders them into some form of template, and it puts them into a shared volume. And then our app actually watches that file for config changes. And then that's how it gets its configuration that has secrets in it. So for an example, Vault can actually manage database credentials for you. So the idea is you give it access to your database, it makes you new users as you ask for them. So every user has a random username and a random password. The cool thing you can do with that is you can say, like, hey, Vault, only let those last for a day or something like that. So then if somebody compromises that app and they get database creds, it doesn't matter. They're only good for a day or something like that. But that means that we need to constantly be watching for changes to those configuration files. And that sidecar helps kind of abstract a lot of those details away from our app. So it doesn't know it's talking to Vault. It just knows it's reading a JSON file. When you run it locally, you just have a static JSON file. So.
Yeah, how do you configure scalability? Because right now we have 2 pods running.
Yep.
Let's say it was 100 users starting an app. You want to step that up to the 5 or 10.
Yep.
How do you
So there's kind of 2 parts to that. So you need to scale your pods. Oh, sure. Question, how do we deal with scaling the applications we're running here? So I'm running 2 copies of this. It's great because nobody's hitting it right now. But if I got a flood of traffic, I might need to deal with more. So I might need to run more copies of this. So there's generally two things to run to deal with that. You run a Kubernetes component called the horizontal Pod Scalar, which what that's going to do is it's going to monitor your pods. You give it some ideas of what it needs to watch for, and it'll be like, oh man, all my pods are too busy, I'm going to make more, right? So now I got 3, now I got 4, now I got 5. So at some point, your cluster runs out of room, right? I can only run so many pods on the single node I have here, right? So then you run another component called the cluster Autoscaler, which what it will do is it'll watch the cluster, and really all it watches for is, hey, am I able to schedule new pods? So generally when you make pods, part of what you should do is tell it approximately what resources it needs in terms of memory and CPU. So it'll watch, and it'll be like, okay, I've got my one node, and I'm at capacity, and you are asking me to schedule a new node, so or a new pod, so I'm going to spin up a new node, and I'm going to join it to the cluster, and that's really how you would deal with scalability. So it'll actually you'll scale up first at your pod level, and then when you hit capacity, you scale up at the node level. So that kind of relies on like the elasticity in a cloud provider. If you're running this on-prem, like obviously like that's not really an option. But if you're running in the cloud, scaling stuff on Kubernetes is actually pretty easy. In addition to that, there's another component that's I think like an alpha or beta called the vertical pod scaler, which the idea is your pod got too busy, I'm just going to make its resource constraints go up, or I'm going to move it to, which may end up moving it to a node that's less busy. That's still in kind of alpha beta. That's again, less for your kind of stateless apps, but more for your stateful applications that I can't just add more capacity. Like if I'm running a database server, I can't just add another database server to a Postgres. Like it doesn't do anything, but I can make it bigger. So Kubernetes helps deal with some of that kind of stuff. Somebody else had a question.
Yeah, can you talk more about the tracing and how y'all landed on Istio and Jaeger? And then first, did y'all look at other tracing?
Yeah, so we're not using Istio yet. I would like to use Istio, but we looked into adding Istio kind of a little bit too late in the project, and it adds a lot more complexity to it. The biggest reason we settled on Jaeger was partly because it is part of Istio. It's called the CNCF, the Cloud Native, I don't know what the other C is, Foundation, Cloud Native Computing Foundation. So it's a first-class project from them, so it's kind of got their backing. It was easy to get set up. A lot of the stuff that we run in Kubernetes that's third-party, we use a tool called Helm to install it. Helm is kind of like a package manager like NPM or apt-get, but for your Kubernetes cluster, in that for the most part you can get like pre-set up sets of YAML, so you don't have to mess with all that YAML necessarily, and you just provide the bits and pieces you want to configure. So Jaeger has stuff for that. I also personally like the separation of the different components. Historically, like the other big tracing piece of software is Zipkin. Zipkin's a single component, which having the multiple components just makes a lot of it easier to scale if you're running in an environment like Kubernetes. The nice thing with Kubernetes is like it's okay to run hundreds of components because they're relatively easy to scale independently. If you're managing this yourself, then obviously that's a nightmare. So that's kind of how we landed on Jaeger.
Did y'all displace any other monitoring tools like Datadog or?
No, so we do use Datadog. The big thing with using the Jaeger stuff is it's free right now. We're not really paying for the Datadog APM stuff. I would in the future like to look at Datadog's APM solution. Obviously, having all of your monitoring stuff kind of all in one place is great. So I'm a huge fan of Datadog. The idea, like they have their outside monitoring stuff. I'm trying to remember what they call it. Synthetic monitoring, where they can kind of ping your service for you now. I would love to have like, okay, it pinged the service, that set off a monitor because it hit some threshold. Here are the stats on the actual infrastructure that impacted. Here's traces for that request. Here's logs for that request. That stuff is all great. Mostly it was just we're not paying for anything right now. So.
Is there some advantage to use Docker or Kubernetes with Angular?
With Angular? So I would argue from a local development standpoint, just having the stable environment is nice. I know like at Kabbage, we have had problems in the past with people running different versions of Node on their machine, just having like inconsistencies like that, so it helps fix some of those things. In terms of running in prod, the biggest thing is, one of the things that I really like about Kubernetes is it gives us a standardized target for how our deployments work. So we have Angular apps, we have Node apps, we have Scala apps, and we have .NET Core apps, all being packaged as a Docker container. And once we have that, the deployment is exactly the same for any of those applications. It's just, I make pods in Kubernetes. So I don't have to worry about, okay, with .NET Core, with .NET, like historically, we've used a tool called Web Deploy to push it out. With Scala, we'd build jar files and have to install the JVM on the machine. With Node, we'd have to manage a version of Node running on that machine. For Angular apps, we'd have to have an Nginx set up and copy the files out, something like that. So just having that standard way of dealing with all these things and a standard way of monitoring these things, standard way of getting the logs out of all these things, for us is a huge benefit. So for us, one of the nice things has been the project that we're running in Kubernetes right now. Like I said, it's a mixture of Node with Angular, C#, and Scala. And we can run all those things, and it makes it a lot easier for us to have this kind of polyglot setup where I don't necessarily care what language you use to build your application. the deployment tooling is the same. So that's really kind of the big benefit.
Speaking of which, did you build all your containers from scratch, or did you find some type of templates or something for your various languages?
Yeah, so it partly depends on what languages you're using. So the Node stuff, like it's mostly kind of homegrown, but we've had, I don't know, like 100 iterations of that. We've been running our Angular apps in Docker basically since the start. For the .NET stuff, we're relatively new to .NET Core, and Microsoft actually has really good prescriptive templates for like, here's what your Docker file should look like to optimize your build. So I think, in reality, I think the .NET Core stuff was probably our first experiences with the multi-stage Docker files, because it has the same kind of stuff as Node apps, where you have, instead of npm install, we have NuGet packages, and you run a package restore. Same kind of deal where I have one part of my build that's significantly slower than everything else, and that's fetching my dependencies from the internet. The actual compile step's relatively quick. So they had a lot of stuff on how to optimize that. They also, for the .NET world, there's essentially what you need to run your application and what you need to build your application. And what you need to build your application is relatively big. What you need to run is a very small subset of that. So we actually build in one container which has the full SDK, and then we copy into a runtime container that has just what we need to run it in the end. So I think the SDK image is something like 400 or 500 megs, and the runtime image is like 30. So it makes all your deploys a lot faster if you're not pushing 400 megs across the network every time you do a build.
What type of tools do you use for your CI/CD?
So we use Bamboo from Atlassian. I'm personally not like the biggest fan of it, but I can't ding it too much because technically I'm the one who brought it here. So, but that was years ago, so I have an excuse. So the biggest thing that we did do with our new stuff using Kubernetes is we started using, there's a thing built into Bamboo now called Bamboo Specs, where you can represent your builds as either YAML or Java code. We started really leveraging that. That comes into kind of like our deployments are pretty standardized now. We can have essentially a templatized build that all you do is you plug in the variables like what's my repo, what's the name of this project, what environment variables do I need to deploy it, and then that's really all you got to do, which is great because the thing we built has something like 20 microservices, each in their own repository with their own builds. So not having to set those all up by hand has been a huge win. Most all the other CI tools at this point have that. You have like Jenkins has a Jenkins file. TeamCity has builds that you can do in whatever the TeamCity, the JetBrains language is. Kotlin. You can do Kotlin stuff. There's somebody that's got Groovy, stuff like that. So I would say, in my opinion, it doesn't necessarily matter too much what tools you're using. I would strongly push you to move more towards creating those builds as code, just because it makes it a lot easier to manage. Anybody else? Sure, I'll totally post that after I make sure it's not broken anymore. Yes, yeah, it's Google Slides, so I can clean up a couple things and I'll totally post them somewhere on the Meetup group. I'll get with you and figure out how to do this. Yep, and like I said, if you think of anything afterwards, I'll hang out here for a bit. And if you think of anything tomorrow or something like that, feel free to hit me up on Twitter or my email. Don't mind any questions. Thanks everybody for coming.